Hello, I'm Dan Gibson, and welcome to the fifth video examining the question, how did the early Muslims calculate the Qibla direction? So far in this series, we've had 4 lecture videos and then 1 discussion video. This is another lecture video, and I'm now calling it number 5 in the series. So far, we've examined these different topics. First, how did the early Arabs calculate or determine the 4 cardinal directions? In that video, we demonstrated a simple method that had been used for thousands of years to accurately establish the 4 cardinal directions. No complex math was involved. A post was driven into the ground, the shadow was followed for several hours, and marked out a true east-west line. A circle could then be made around that as well. In the second video, we established the making of a north-south line, east and west, and then we went on to look at the Arab windrows and 32 directions that were marked out on the circle on the ground. Third, we examined how the early Arabs measured distance, and we looked at various methods that were used, especially that of counting steps as a merchant caravans as they crossed the desert. This practice was noted by Roman historians who saw it and who wrote it down. In the 4th video, we looked at the mindset of the Arab master caravaner who was always measuring distance. He was the navigator and he was counting steps. His men counted steps as they traveled, and they calculated the distance and the angles as they went along. And then there was the discussion video with 3 other men who had backgrounds in navigation and who could understand and share with us about what I was lecturing on. Now, in this video, we want to see how the navigational techniques were used by mosque builders to accurately establish the Qibla direction. Again, no complex math was involved. Notice that I use the word navigation. I'm not referring to astronomers and mathematicians that the later Muslims excelled in. These are slightly different sciences, as you will see. Some of you are aware of the strong position that Dr. David A. King has taken against my measurements of early Islamic Qiblas. Dr. King has written several hundred papers and articles in his lifetime, and some of his papers have also been compiled into books, several books. In all of his writings, Dr. King mentions the navigators of Islam only a couple of times. For instance, when speaking of Gerald Tibbitz's translation of Ibn Majid and Suleiman al-Mahri, that's here. I have that translation. I've been studying that for several years and referring to it as a reference book. Dr. King calls it Islamic folk astronomy, and it's not of the science of astronomy, which was based on what he calls observation and calculations. Dr. King argues that the great science of the medieval era, the great scientists were astronomers and mathematicians, not navigators. And he admits that only these 2 navigators that are the ones that he mentions in passing. The astronomical lore of the Arab navigators is perhaps best understood as a branch of folk astronomical tradition. Most of what we know about it is contained in the writings of 2 South Arabian navigators from the 15th and 16th centuries, Ibn Majid and Suleiman al-Mahri. Their major works have been published from the few available manuscripts by I-Khoury, and particularly valuable study has been prepared by J.R. Tibbets. And King continues, in general, the Muslim astronomers had little interest in the folk traditions, although from the 9th century onward it was well documented and readily available to them, but they never even mentioned the astronomy of the navigators. King is pointing out here that in medieval times there were 2 groups. On one side, the astronomers and mathematicians, and on the other side, the navigators and those doing the folk astronomy over on this side. And they didn't communicate much with each other. So Dr. King has studied one stream, that is the astronomers and the mathematicians, and that's where he excels. He's an expert there. On the other hand, I have studied the techniques used by the navigators. In the ancient Islamic world, the astronomers and the navigators ignored each other. And they said despairing things about one another. On one side, the astronomers had access to the newly translated Greek books. They were transforming the Arab view of astronomy and mathematics. The navigators, on the other hand, used old-school tools and old ideas and traditions. Now, during the last few months, I've slowed down in the making of the YouTube videos, and I've been concentrating on reading the medieval Islamic astronomers and geographers, the very ones that Dr. King reads. You see, I think Dr. King has not only studied the science of medieval writers, these astronomers and mathematicians, I think he's embraced their attitudes towards the navigators. For example, in his review of my book, Early Islamic Qibla, he states, Gibson also introduces the Arab windrows, but this was used only by Arab navigation, certainly not for finding the Qibla to Mecca. That's on page 362. Now, I don't mind this kind of statement. I don't find it very helpful, though. As far as I can see, everything that the navigators did was part of a system of technique that allowed the merchant navigators to travel at distant points over the horizon. It was all about picking a spot over the horizon and then being able to say, the city we want to go to is there, and how do I navigate to that spot? That's what the Qibla was all about. I want to build a mosque here. I want to face a distant place over the horizon. That's the whole purpose of navigation, and determining the Qibla direction was exactly the same problem, and it was solved with exactly the same tools and methods. That's why I turned to the navigators, not the astronomers, to discover how the Qibla was determined in the first years of Islam. Dr. King goes on to complain about my writing, and he says, Gibson's bibliographical data, his citations throughout the book leave a lot to be desired. On the history of Islamic astronomy and mathematicians, there's not a single item. Exactly. Since I'm coming from the navigation point of view, why should I quote the astronomers who are hundreds of years later using sciences that they learned from Greek sources? Dr. King seems to have unwittingly fallen into the pull and tug between the navigators on one side and the astronomers and the mathematicians on the other side. In his paper, Folk Astronomy and the Service of Religion, the Case of Islam, Astronomies and Cultures, King boldly states, the astronomical lore of the Arab navigators is perhaps best understood as a branch of folk astronomical tradition. The only practical device used by the Arab navigators besides the compass was a kamal, a simple knotted rope for determining latitudes by means of the pole star. A little later, he says, the early navigators developed all that they required of this practical science long before the Ottoman period and the beginning of the 16th century, and they borrowed nothing from the scientific tradition. Dr. King attacks me again in a paper, which is from Petra back to Mecca, when he states, Gibson imagines that the Qibla determinations come out of navigation, neglecting to say precisely what documents he means, where he found these documents, or precisely what he found in them. Nonetheless, he makes his imaginings into a personal truth, but it surely doesn't rise to the level of scholarship, all rather Trumpish. I know of no such documents. Well, that's interesting, because he does know. I'm going to quote the very same sources that he quotes. And as I said, during this last month, I was digging through all of the astronomers and the mathematicians over here, reading through them. I'd only done a cursory study some years ago. Now I was poured through them. I took basically 2 months and went through all of everything Dr. King said and looked through all the source materials and so forth till my head was spinning. And I was reading it through, and I discovered that Dr. King does know about the early Qiblas. He does know how they did it. He's even written about it and said, but he just sort of dismisses what the navigators were doing. So I'm referring to a method of Qibla finding that is described by several of the medieval astronomers. The Syrian astronomer al-Battānī wrote from the Islamic city of Raqqa about 297 AH, that's 910 CE, and he describes an early method of determining the Qibla. Other writers also touch on this topic, such as Khwārazm, Ḥabash al-Ḥāsib. He's in Baghdad around 625, and he recorded a similar method. Well, then he adds many more calculations to try to make it more accurate and improve on it. But King writes about that in Astronomy and Islamic Society, which he published back in 1996. Now, I have al-Battānī's book here beside me. And so I've been looking through this and reading it. It's a fascinating book. It's written a long time ago. This is, and there's a lot in here that we can read. And he mentions an approximate method, and Dr. King describes it. Let's let Dr. King give us a description. This is from Chapter 4, called Chapter 4, Astronomy and Islamic Society, first published in 1996. This is on page 143, Dr. King writing. Another approximate method mentioned by al-Battānī was widely used and remained popular until the 19th century. This method could not be simpler. First, he says, draw a circle on a horizontal plane, like on the ground, draw a circle, and mark the cardinal directions. Oh, that's exactly what we did in the first two videos. Then we marked out the degrees on the circle. Then Dr. King says, then draw a line parallel to the north-south line and an angular distance measure on the circle equal to the longitude between Masjid al-Haram and the new locality, and the other line parallel to the east-west line, and an angular distance equal to the latitude difference. Then the line joining the center of the circle to the intersection of these two lines is the Qibla. Now there is an illustration of what al-Battānī is saying on your screen there. Let's start again from the beginning, though, in case you missed the first videos. Begin with a large, flat, horizontal surface where you're going to build. Pound a wooden stake into the ground. The larger, the better. Mark the shadows with the stick as it moves along through the day, and then draw a line through them, and then you get your east-west line. Then mark two arcs, same-size circles. You can use this to find a parallel line, and then you can mark the north-south line, and you're marking this all on the ground. So then you draw a horizontal line across the top. At the place, you count the number of zams that are there, the difference between the two locations, and mark that. And then you mark the number of zams. The hard part is getting the east-west circle, and you put them over here. We're going to explain this again, so I'm just mentioning it briefly. This is how it worked. You draw this, and these lines intersect. This is exactly what Battānī has been describing to us. Al-Battānī doesn't explain how every step is made, but he draws the very same chart, draws the very same circle on the ground, and puts in all these points, and that al-Battānī. Now, maybe he didn't know all the details, but he certainly gets about 80 to 90% of everything that should be done in drawing this out. We can learn some of the details later, and I'll explain why, because later on it was called the Indian Circle. And this is an old navigational tool, and you can look it up, you can Google it, you can see. Now, the question is, where did it start? Did the Arabs start it and take it to India? Did the Indians use it first and did it go to Arabia? We have no idea, except that many hundreds of years later, after the founding of Islam, it was called the Indian Circle. So that is what we call it, and you can Google it, and you can look more at it on Google if you want. I'm going to describe it here. Now, the first 8 steps could be done with great precision. The larger the circle, the taller the post, the more accurate it became. So you would want to drive a large post into the ground, make it a large circle around it, so the shadow from the top of the post could be traced. And there's a record that the Abbasid Caliph Ma'mun, that was back in 830 CE, he was so obsessed with accuracy that he asked his scientists to make some very accurate measurements. The larger the better. The observation commissioned by al-Ma'mun took place only when he had read the books of the Greeks, that the equivalent hissa of 1 degree was 500 stades, which was the unit that they used for measuring distances. But he did not find among the Arab translators significant knowledge about its length compared to known units. You catch this. At this very time, Greek thought, Greek influence is coming in, and they're translating it, and they're having a problem with how long is a state, how long is a hustle, and figuring it out. Kind of like between kilometers and miles when you switch over. It's kind of hard, and the whole Arab society is switching over at this time. So the Arabs at the beginning of the Abbasid era were obsessed with establishing accurate measurements. They were aware of the old methods of calculating were used by the navigators using ZAMs, but now they were using the new methods that seemed to be much more accurate at greater distances, trying to use the Greek methods and other measurements and introducing new maths that were coming along. Remember, the new astronomers and mathematicians were gaining knowledge and ideas from literature written in Greek. Greek was not just the language of the Greeks, it was also the language of the educated in the Roman Empire, in the Byzantine Empire, and all those that followed during the time of Ma'mun. The library in Baghdad was filling up with books that were translated from Greek sources. Now, these new astronomers and the mathematicians were captivated by these new sciences. Now, there is an important occurrence at this point. The new sciences that they embraced from the Greeks used 360 degrees in their circle, just as the Babylonians had. The astronomers and the mathematicians spurned the old navigators with their old system of 224 degrees in a circle. That was old school. They had nothing to do with that anymore. And so the division between the astronomers and navigators widened even more. The old techniques stayed alive only among the navigators, who still found the old methods to be useful to do rudimentary navigation. And so you will find virtually nothing about the techniques of the navigators in the writings of the astronomers and the mathematicians. They don't even use the same units of measurement, not even the same numbers of degrees in a circle. That is why my explanation uses 224 degrees and measurements called ZAMs, because I'm looking to the navigators. Now, he's measured how far north and south Masjid al-Haram is. At this point, he draws a horizontal line through his circle. He knows the location of Masjid al-Haram because he's been measured before, and every Muslim who's ever gone to Masjid al-Haram has measured it. Probably the kids all wanted to learn, and they all practiced measuring. It was a known number how far north. So he simply counts the number of ZAMs that it goes up and marks on his circle there where Masjid al-Haram is that far north or south. Now, the mosque builder, he's in a new location. So remember, he has to do a little bit of math. Subtract here. He has to know how far he is and how far Masjid al-Haram was. And he takes the difference and he marks that on his chart. Let's imagine that the new mosque is to be built in Jerusalem. The architect would measure its height, the height of the North Star, at 17 Isba and 4.5 Zams, or a total of 123.4 Zams. He would know that the height of the North Star in Petra would be 16 Isba and 5 Zams, or 117 Zams. So the difference is 6.5 Zams. That is equal to 156,000 steps. 168 kilometers is 1 Zam, and 8 Zams is 1,344 kilometers. So that would raise the pole 1 Zam in measurement. Now, all he needed to do was measure the difference between the two locations and chart it on his circle, measuring the horizontal line to the circle and just measuring up the distance between and marking that's where Qibla, Masjid al-Haram is somewhere along that line. The next step is determining how far east or west he is. Now, many of the early maps I've seen use the city of Alexandria as the focal point. Today, the British use Greenwich Mean Time because the counting for them started in Greenwich in the UK. In ancient times, the circle of the earth was most often calculated from Alexandria, the location of the original Alexandrian library and the museum established around 250 BC. Ever since then, Alexandria has been one of the main places that the direction and distance was measured from. For the Nabatean merchants, Alexandria was very close, large city, close access to Rome. It makes sense they may have measured from Alexandria. They may have measured directly from Masjid al-Haram. So from Alexandria to Petra, it was 3.2 zams and a little bit, or 540 kilometers. The architect would measure just over 3.2 zams and then draw the line vertically downward. Where the two lines intersected, both the Qibla direction was represented by that point where they intersected, and he would draw a line from the pole out there, and that's his Qibla direction. As long as the Arabs kept good track of east-west distances, the Indian circle could accurately determine the Qibla direction within a degree or two. Remember, the Arabs had been measuring the distances from 250 BC to 500 AD, which is more than 750 years of checking and double-checking distances. There are only two places in this system that you can introduce an error. One was if there was something wrong with the concept of the Indian circle itself, which there was, because it did not take into consideration the curvature of the Earth. But how much would that affect the outcome? We're going to examine that in the next video. The other place of possible error was if the Arabs counted the distance east or west wrongly. And we're going to test that out in the next video as well. I'm Dan Gibson. This has been another video in the series Navigation and the Qibla, and here we've been looking at the Indian Circle, and next video we will examine in detail the two challenges that we have, the curvature of the Earth and the accuracy of their east-west measurements.